Principles. So we're going to use the concepts of pressure that we learned to apply it to something somewhat useful. And this, of course, is the basic rule, and then we'll go through the math of it. Of course, there's math to it to make it useful. What this is saying is, maybe you could ignore my writing for a second here, but what this is saying is, if you look at a hydraulic hoist, all the fluid is in the same containers, in the same vessel. So that means the pressure on any one point in here is constant. So the pressure at this point is exactly equal to the pressure at this point. It's all closed in. There's no atmospheric pressure in this. We're just looking at the pressure inside this vessel. However, and the way this device would work is you apply a force right here on this small part, and that would be used to push up on a vehicle. And that's really, we're going to use this to gain mechanical advantage. Okay, this is a type of machine. So the equation, well, first of all, the things then, what I'm writing here, what these all are, is I'm saying Fs is a small force, and you apply it to a small area, As. And what you can get from that is a big force, which is this huge car, the gravity force on that car, the weight of that car, right, is the big force, FL, large force, I guess, and it's applied over a large area. So a small force in, you can achieve a large force out, because you're able to push down in here with something achievable to obtain moving a big car. And that's how this machine works, okay? So here's the equation. We're saying the pressure is constant. That means that since P is force over area, small force over small area, right? The pressure right here equals the pressure right here. So that's the large force in the large area. So all you have to do is apply a force somewhat larger than Fs. So if Fs was 10 newtons, if you applied 11 newtons, you would have enough force for this not to be in equilibrium, but to actually be able to push up on this thing. Okay? So here's our, these are the rearranged forms of that equation, by the way. So this equation is not very useful. What is useful is the way these Pascal's law problems go is you're always looking for one of the things. You know, what's the maximum load you could pull up? That would be FL. What area should you design in to here? That would be AL, right? What's the minimum force you need to apply to be able to lift the car? That would be Fs. Okay? So an example, so we have a car, so this is this example, right? There's its mass, the area of the large piston, so AL will be 0.22, and the area of the small piston is 0.013. So just looking at my givens then, I'm given a mass, I'm not given FL, but the thing you need to know, this is important, that FL is going to be the load that you're lifting, so ML times G. It's going to be the gravity force of the car, okay? So there's our FL, there's our AL, there's our AS. What minimum force must you apply? So you choose this form of the equation. And so to push up a load of 13,000 newtons, you need to apply a force of 800 newtons. And if you remember mechanical advantage, FL over FG, that's about, you know, it's about 15. That's a good mechanical advantage you're getting out of that. Okay, and then it says determine the pressure inside the press. So you could use any of these formulas, like P equals either Fs over As or FL over AL. So you could choose whichever one you want. I chose the large, so I said 13,720 divided by 0.22, which you could choose. You could choose the small, whichever. You could have said 811 divided by 0.013. Another example, in a mining operation, we have a hydraulic jack, same idea, exerting a maximum force of 2,200 newtons on a small piston. So that must be our Fs because it's on the small piston, okay? The surface area of the small piston is this, and the surface area of the large is 2. Calculate the force applied to the large piston and the maximum mass that you could put on that jack. Okay, so looking at our givens here, we're obviously looking for force on large pistons, so that's FL. So that ends up being 44,000 newtons. Then, in order to find the maximum mass that you can lift, then you have to use this equation here. So generally, if the load force, like I said, is the gravity force, so it'll be mlg almost all the time. Okay, so then you have this one, you rearrange it for ml, and so this little piston can lift a mass of 4,500 kilograms. You know, on 0.1 meters squared of area. Okay, that's it on Pascal's law.